Okay, we need to finish this problem out. In the last video, we had gotten it down to where we had taken the square root of both sides. The square root of 9 would be plus or minus 3, and the square root of the square, that is, undo each other, and we would have x minus 6. So what we have at this point is really two different equations. I'm going to come up here so we can see a little better. We have now 3 equals x minus 6, or we also have negative 3 equals x minus 6. So solving this first equation, if I add 6 to both sides, that would be 9 equals x. Or over here, if I were to add 6 to both sides, then we would get 3 equals x. Okay, so what we need to do now is we need to double check these and make sure that they will work. Let's try the 9 first. If I plug 9 in here in place of x, then that would be 9 minus 6. Well, that would give us a 3, wouldn't it? So taking the log of 3, that's an okay thing to do. So that seems to be an answer right there. What about this one, though? Here we have x equals 3. If I plug a 3 in here in place of x, 3 minus 6, well, that would be a negative 3. We cannot take the log of a negative number. That's not possible. So this is actually an extraneous answer. It's not part of our true solution set. That's why it's so important to go through and double check your answers, because where it might appear that it would be a correct answer just from doing the work, but it doesn't actually work in the domain of the original problem. So we have to be careful. All right, let's try another one here real quick. And with this one, we can see that my screen is kind of lobbing it off. Actually, there should be a parenthesis back behind that 4. So that's what's going on there. Okay, here we have this very, very long looking problem. Let's look at just the left-hand side of the equal sign before we do anything else. Here we have two logs that are separated by a minus sign. In order to put those back together, we would have to use division. So this would be log base b of x minus 8 over x plus 7. Now on the other side of the equal sign, we have a very similar situation. We have two logs separated by a minus. So I'm going to put those together, again using division. So x plus minus 8 over x plus 4. Now we have log equal to log. So that means that the arguments must be the exact same thing. So in this case, x minus 8 over x plus 7 must equal x minus 8 over x plus 4. Now this is kind of a very interesting situation here. We could do the cross product and set those equal to each other and solve it, or we could also look at this and use some logic. Here both of our numerators are already the same thing. So in order for both of these to be identical, the denominators must also be the same. So I could pull that out and say x plus 7 must be the same as x plus 4. And if I go to solve that, if I subtract x from both sides, that cancels the x's and I'm left with 7 equals 4. This is not a true statement. In fact, for this problem, there is no solution. And that does happen sometimes. So if you get something like this that doesn't make any sense at all in the world, that's telling you that there is no number that you could plug in here for x and make that a true statement.